Picture this. You're floating in the vast emptiness of space. Below you lies a shimmering blue jewel, the Earth. Its white clouds swirl over endless oceans, and its green and brown lands stretch like intricate patterns of art. From space, Earth looks serene, timeless and unchanging, but nothing could be further from the truth. Beneath its tranquil appearance lies a story that spans billions of years, a story of fire and ice, of creation and destruction, of life and death. Today we'll journey through this epic tale, exploring how Earth came to be, how it transformed into the vibrant planet we know, and what its future might hold. So buckle up. Our time machine is ready. 4.5 billion years ago, our solar system was beginning to take shape. The sun, newly born from a collapsing cloud of gas and dust, blazed at the center of a swirling disk of particles. In this chaotic environment, tiny grains of rock and metal collided, sticking together through static electricity. Over millions of years, these grains formed larger bodies called planetesimals, the building blocks of planets. Among these planetesimals, one grew larger through constant collisions. This sphere of rock became Earth. At first, Earth was a fiery, molten ball of magma. Asteroid and comet impacts kept its surface in a molten state and delivered key ingredients like water and organic compounds. Above this surface, a thick atmosphere swirled, filled with carbon dioxide, methane, ammonia, and water vapor. Lightning flashed, and volcanic eruptions added gases to the mix. It was a world of extremes, with temperatures so high that metals flowed like rivers, and oceans of magma stretched across the planet. Within this chaos, Earth's layers began to form: a solid iron core, a liquid outer core, a mantle of semi-molten rock, and a thin, rocky crust. This differentiation would prove essential, as Earth's magnetic field, generated by its core, protected it from the sun's radiation. This fiery beginning was nature's crucible, refining the raw materials for oceans, continents, and life itself. Chaos and destruction laid the foundation for the planet we now call home. Not long after Earth's fiery beginnings, an event occurred that would change our planet forever. A Mars-sized body, now known as Theia, collided with Earth in a cataclysmic impact. The collision melted rock and reshaped Earth itself. The impact ejected a massive amount of material, rock, dust, and molten metal into space. This debris formed a glowing halo around Earth, slowly clumping together under gravity to create a new celestial body, the Moon. At first, the Moon was much closer to Earth, appearing enormous in the sky. Its strong gravitational pull caused massive tides in Earth's molten surface and early oceans, redistributing heat and playing a crucial role in Earth's development. The Moon's steady gravitational influence also stabilized Earth's axial tilt, preventing extreme wobbling and ensuring relatively consistent climates. This stability created an environment where life could eventually take root and thrive. Without the Moon, Earth's climate and seasons might have been far less predictable. The Moon's formation wasn't just a byproduct of a violent impact, it was a transformative moment that shaped Earth's destiny and made life as we know it possible. As Earth's fiery surface cooled, an extraordinary transformation began. The thick, steamy atmosphere allowed water vapor to condense, and torrential rains poured down for thousands of years. Valleys filled with water and vast basins became the first oceans. These early oceans were hot, mineral-rich, and shrouded in dense clouds. Lightning storms crackled across the skies, and volcanic vents pumped minerals and heat into the water, creating a restless environment. Comets from the far reaches of the solar system bombarded Earth, delivering frozen water and organic molecules. Each impact enriched the planet's chemistry, setting the stage for something remarkable. Though devoid of organisms, these oceans were brimming with possibilities, a chemical soup where basic molecules mingled and combined. They became the cradle of potential, waiting for the spark that would ignite the story of life on Earth. Today, those first oceans are gone, their waters having cycled through countless forms and eras, but they remain a symbol of Earth's profound transformation, an ancient memory etched into every drop of water we see today. Deep within Earth's ancient oceans, life found its first foothold. These waters were dark, mineral-rich depths punctuated by hydrothermal vents, chimneys spewing superheated water and nutrients from Earth's molten interior. It was here, in these extreme conditions, that life began. From a mixture of water, carbon, and other elements, the first microscopic life forms emerged. These simple, single-celled organisms clung to life around the vents, using chemical reactions for energy. They thrived in environments where no other life could, laying the foundation for the diversity that would follow. Among these pioneers were photosynthetic microbes, which harnessed sunlight in shallower waters. By converting sunlight into energy, they released oxygen as a byproduct. Initially, this oxygen was absorbed by iron in the oceans, creating rust deposits on the seafloor. Over time, oxygen began to escape into the atmosphere, transforming Earth forever. The slow buildup of oxygen over millions of years created breathable skies, enabling the evolution of more complex life forms. This great oxidation event marked a shift from a barren world to one teeming with potential. Even today, the descendants of these early microbes thrive in extreme environments: hot springs, frozen tundras, and ocean depths. Their legacy endures in every living thing on Earth, a testament to life's resilience and creativity. For billions of years, Earth's biosphere was dominated by simple, single-celled organisms. These life forms quietly shaped the planet, transforming its oceans, land, and atmosphere. But around 600 million years ago, a transformation began to unfold, a revolution in the history of life. During the Ediacaran period, the first multicellular organisms appeared. These soft-bodied creatures, unlike anything alive today, spread across the seafloor, absorbing nutrients directly from the water. They were Earth's first experiment with complexity. As the Cambrian period dawned roughly 540 million years ago, life underwent an explosion of diversity and innovation. Known as the Cambrian explosion, this period saw the emergence of creatures with specialized body structures, including skeletons and shells. Earth's oceans became a stage for a dazzling array of forms. Jellyfish drifted gracefully through the water, trilobites scuttled along the seafloor, and worms burrowed through sediments. Predators appeared, sparking an evolutionary arms race that drove the development of sophisticated defenses and behaviors. This era marked the first appearance of many major groups of animals we recognize today, including arthropods, mollusks, and early chordates. The Cambrian explosion introduced new ecological dynamics, laying the groundwork for the intricate ecosystems that would later spread onto land. This pivotal chapter reminds us of life's resilience and adaptability. It shows how, in the face of changing conditions, life flourished and evolved in endlessly surprising ways. For over 3 billion years, life thrived in the oceans. But around 400 million years ago, life began to explore a new frontier: land. Plants were the pioneers. Tiny moss-like organisms were the first to colonize barren rocky surfaces. Over time, they evolved into more complex forms with vascular systems, transforming Earth's deserts into patches of green. As plants flourished, animals followed. Arthropods such as scorpions and millipedes adapted to life on land by developing exoskeletons to prevent dehydration. Not long after, vertebrates emerged. Amphibians, capable of living in water and on land, crawled onto muddy shores, using their muscular fins to navigate this new terrain. The Earth during this time was a vastly different place. Towering ferns and club mosses formed the planet's first forests. Insects grew to enormous sizes, and the land echoed with the sounds of new life adapting to its environment. This transition wasn't just a physical migration, it marked a monumental leap in evolution. Earth's landmasses became vibrant ecosystems, paving the way for the rise of terrestrial giants and the biodiversity that defines our world today. For over 180 million years, Earth was the domain of the dinosaurs, some of the most remarkable and diverse creatures to ever exist. This era, spanning the Triassic, Jurassic, and Cretaceous periods, saw life reach astonishing complexity and scale. The journey began in the Triassic period, when the first dinosaurs emerged after a mass extinction event. Over time, these humble beginnings gave rise to the giants of the Jurassic and Cretaceous periods. The world during the Age of Dinosaurs was vastly different. Lush forests and vast inland seas created fertile environments for diverse ecosystems. Dinosaurs adapted to these environments with extraordinary versatility. The towering Brachiosaurus grazed on treetops while the heavily armored Ankylosaurus relied on its bony plates and tail for defense. Pterosaurs ruled the skies while oceans teemed with massive marine reptiles like Mosasaurus. Recent discoveries suggest many dinosaurs like velociraptors were covered in feathers, hinting at a direct link to modern birds. Some species even displayed social behaviors, living in herds or caring for their young. Around 65 million years ago, a cataclysmic asteroid impact changed Earth forever. Wildfires, tsunamis, and a nuclear winter caused nearly 75% of life to perish, ending the Age of Dinosaurs. Yet from this tragedy arose new opportunities for mammals, birds, and other resilient species to inherit the planet. A reminder that even in devastation, life finds a way to adapt and endure. With the extinction of the dinosaurs, Earth entered a new chapter, one that allowed mammals to rise and thrive. These survivors, once small and nocturnal, diversified and adapted. Over millions of years, they evolved into a variety of forms, from woolly mammoths roaming icy tundras to cheetahs sprinting across savannas. Earth's landscapes changed dramatically during this time. Mountain ranges rose, seas retreated, and ice ages came and went, shaping the environments in which mammals lived. Around 2 million years ago, a new kind of mammal emerged: early humans. These hominins, like Homo habilis, were tool makers and problem solvers. Later species, such as Homo erectus, mastered fire, enabling them to survive harsh conditions. Humans spread from Africa, adapting to diverse environments. Along the way, they left evidence of their creativity, from cave paintings to agricultural settlements. The rise of civilizations marked a turning point, as humanity began shaping the planet on an unprecedented scale. But this rapid expansion came at a cost. Climate change, habitat destruction, and species extinctions highlight humanity's impact. Yet, we are the first species capable of understanding these consequences and working to mitigate them. The choices we make today will shape the Earth's future, balancing the legacy of resilience and ingenuity with the responsibility to sustain life. Over the past 2.4 million years, Earth has experienced ice ages, periods of intense cold when glaciers advanced across continents. These frozen epochs were part of a natural cycle driven by changes in Earth's orbit and tilt. Advancing ice sculpted deep valleys, fjords, and features like the Great Lakes. Life adapted to the cold. Woolly mammoths used their tusks to dig through snow for food. Saber-toothed cats hunted large prey with powerful canines. Early humans developed warm clothing, built shelters, and harnessed fire to survive harsh winters. Ice ages pushed species, including humans, to innovate. Survival needs inspired advanced tools and tighter-knit communities. The last ice age began 115,000 years ago, with glaciers blanketing much of the northern hemisphere. Lower sea levels exposed land bridges, allowing species to migrate. Around 12,000 years ago, the ice age ended, leaving a transformed world. Glaciers retreated, revealing fertile plains and lakes. This warming climate marked the start of the Holocene epoch, creating stability for agriculture and civilization to thrive. The ice ages shaped the landscapes and resilience we see today. Welcome to the Anthropocene, the age of humans. In this era, humanity has reshaped the planet on an unprecedented scale. The Industrial Revolution transformed cities and industries. The digital revolution connected billions, unlocking knowledge and innovation. But our progress has consequences. Deforestation, pollution, and climate change have profoundly impacted the planet. Rivers and oceans bear the brunt of waste, while greenhouse gas emissions drive global warming. Yet, the Anthropocene is also an era of potential. Renewable energy sources like solar and wind are replacing fossil fuels. Urban spaces are being reimagined with green roofs and carbon-neutral designs. Conservation efforts are restoring ecosystems and bringing species back from the brink of extinction. This moment challenges us to rethink our role as stewards of Earth. Will we exploit resources recklessly, or will we build a future where humanity and nature thrive? What lies ahead for Earth? Will it remain a vibrant, life-filled world, or will it face challenges too great to overcome? The future of our planet is unwritten, a blank canvas, waiting for the choices humanity makes today. Imagine a world where humans and nature coexist in harmony. Cities powered entirely by renewable energy hum quietly, their streets lined with trees and bustling with electric vehicles. Science and technology hold incredible promise. Breakthroughs in clean energy, carbon capture, and sustainable agriculture could reverse the damage of the past. Innovations in artificial intelligence and space exploration may even open new frontiers, helping us learn from other worlds while preserving our own. But this vision depends on the choices we make now. Every effort to protect endangered species, reduce emissions, and restore ecosystems is a step toward a brighter future. Education and awareness are powerful tools, inspiring the next generation to dream bigger, innovate smarter, and act more responsibly. The story of Earth is still unfolding, and we are its authors. The question is no longer whether we have the power to shape the future. It's whether we have the will to do so wisely. Together, we can ensure that the next chapter in Earth's story is one of hope, resilience, and harmony. What kind of story do we want to tell? It is our responsibility to decide.